Hello, welcome to this video. This is 1A.7. We're talking about even and odd functions. So I'm going to introduce you to this vocabulary and how to determine if a function is even or odd. All right, so what we're going to go ahead into is we are going to be given a point on a graph of an even or odd function and be able to determine another point on that graph. That's how you know if you're successful in this lesson, and if you can use symmetry to determine whether a function is even or odd. So, what is an even and odd function? Here's the definition. A function is even if it is symmetric with respect to the y-axis. And here is a visual example of an even function. This means that the graph of the function will be unaffected if it's reflected over the y-axis. And then similarly too, what I want you to see is that I have a point on the graph here. Okay, my x value is -4, 2, and on the other side of the graph I have an x value that's 4, 2. We can go ahead and see this also algebraically. If given a function f, if I plug in -x, f of -x, and I get out f of x, I get the original function out, this is what's called an even function. So this means that if you substitute in -x into the function and get the same exact signs as the original polynomial, then it's even symmetry, okay? Another example of this would be a function like y equals x squared, right? So if I call this function f, and I said, okay, what is f of -2? Just kind of informally. Well, that would be -2 squared, which gives us 4. Okay? And now I'm going to plug in the opposite x value, So I plug in f of 2. If I plug in that, 2 squared we know is 4. This is an even function. That's informal. We'll do this formally later. But here's the kind of general idea. If I plug in the opposite x and I get the same y value or the same function out, the function is even. Let's go ahead and look at an odd function. An odd function is symmetric with respect to the origin. And here's a basic example, y equals 3x over here. That means the graph of the function will be unaffected when reflected over the x-axis and then the y-axis or the origin, okay? Or, if you're big into rotations, 180 degrees about the origin. Similarly, algebraically, if I go ahead and given a function f, if I evaluate -x in my function and I get out -f of x, again, if I plug in the opposite x value and then here I get the negative function, the negative of the original function, then it's odd. This means that if you substitute in -x into the function and get the exact opposite signs of the polynomial, then it's odd symmetry. I again wanted to show you another just general example. Y equals x to the power of 3, and I'll call this one g. So if g of -2, if I evaluate this, -2 cubed, this gives me -8. And then I evaluate g of 2, the opposite x, I'm going to get the opposite y value. We get 8, okay? So this is an odd function. Opposite x gives you the opposite y value. Okay, so let's go ahead and look at some visual examples here for a second. I have example number 1, and what I notice about this is that it looks like it's centered right here on the y-axis. If I fold this side over onto this side, they are symmetrical, so this is an even function. That's an example of an even function. Okay, and then for example number 2, what I want you to see is that we have a reflection about the origin. That portion is reflected over onto this portion. Doesn't quadrant 2 and quadrant 4 look the same, and quadrant 3 and quadrant 1 look the same? So they're reflected across the origin, reflected to the other side. This is an odd function, Now example 3, let's go ahead and look at this function. For this function, this is an example of neither even nor odd. I'm not symmetrical with respect to the y-axis. If I went ahead and kind of split it here, this side does not reflect onto this side, and similarly this quadrant does not reflect up here into this quadrant. So this is neither even nor odd. Okay, 3 examples here. I want you to pause me, go ahead and try these. Okay, hopefully you paused. Example 1 is neither even nor odd. It's not centered on the y-axis, not symmetrical. But example number 2 is, if I went ahead and folded this half over here, it would match exactly, symmetrical via the y-axis. And then example 1 is not symmetrical across the origin either. I have none of this repeated or reflected over here into these 2 quadrants. So example 3, however, is. I could go ahead and reflect this over into quadrant 1. Example 3 is odd. All right. Let's go ahead and look at some example multiple choice questions that the AP Precalculus exam loves to ask. They say, the polynomial function g is an odd function. If g of 2 equals -5, which of the following is also true of g? So they give us some information, and for these problems, I love to go ahead and just make a sketch. I just love to give a visual representation. So here's 2. -5 is going to be down here. And if this function's odd, I expect this to reflect over the origin. And so I'm going to have -2, +5. It will be up here. Okay, so based upon this, if this is true and it's odd, then this would also be true. So g of -2 equals a +5, which is C. The other question that you may see on the AP exam says here, the polynomial function k is an even function, If k of -1 equals 7 is a minimum, which of the following is also true of k? So again, helping yourself, just make a sketch. I have k of -1. Here's -1 is 7, so I'm up here. And if this is true, then k of 1 equals 7 is also true if it's even. Now they also say here that this is a minimum. So if I go ahead and I draw just some polynomial function, let's say something like this, I have a minimum here, and then this is also going to be a minimum. Okay, so k of 1 is also 7, so k of 1 is also 7. So C and D go out the window because it's not -7, it's not odd, it's even. And this point will also be a minimum. All right, here's a practice problem. Please go ahead and try this example, and then I'll talk about the results in a second. All right, here we have the polynomial function d, they say is an odd function. If d of 4 equals 2 is a minimum, which of the following is also true? So again, sticking with this, just draw a quick sketch. Example, d of 4 equals 2. It'll be a point right here, and they say this is a minimum. Well, if it's odd, then the opposite x, -4, is going to give me the opposite y. Okay, and it's going to reflect. So I'm going to have a curve that looks like this. Okay, so this would be a relative maximum. Okay, so k of -4 equals -2. So C and D go out the window, and it's going to be a maximum. So our answer is B. Okay. Let's go ahead and look at algebraically how I determine if a function is even or odd. And it's very, very important to remember. A function's even if I plug in the opposite x and I get the same y. A function's odd if I plug in the opposite x and I get the opposite y. And then it's neither if neither of those two cases pops up. So example 1, f of x equals 5x to the 4th minus x squared plus 4. I'm going to go ahead, I'm going to take f and I'm going to plug in the opposite x. I'm going to plug in -x. So I'll copy everything down just the same. 5 times -x to the power of 4 minus x, which is -x, to the power of 2 plus 4. Now I'm going to go ahead and raise negative x to the power of 4. Well, a negative times a negative is a positive, times a negative is negative, times a negative is positive. So this is going to give me 5x to the power of 4, right? So negative x times negative x times negative x times negative x. This gives me a positive x to the 4th. And then negative x squared. This is going to give me a negative. Well, negative x squared is a positive x squared plus 4. And what I hope you see is that this function matches exactly with our function. This is f of x. The same thing. The opposite x gave me the same y. Function's even. All right. G of x. Let's go ahead and look at g. Again, I'm going to do the same thing. I'm going to evaluate negative x. We'll plug in negative x. And so here we get negative x to the power of 3 plus 5 times negative x. So wherever you see an x, you just replace it with a negative x. Now negative x cubed, this is going to give me negative x cubed. And 5 times negative x is minus 5x. Now this function is not the same as this. In fact, the signs are exactly opposite. I wonder if it's odd. Well, if I factor out a negative, if I take a negative out, both of these signs change. And lo and behold, I have the same thing as g now. So this is the opposite y value, or the opposite function. This is an example of an odd function. Okay, third example. What do you think this one's going to be? I bet you know. Let's evaluate h of negative x. So wherever there's an x, I'm going to plug in negative x to the power of 3 plus negative x to the power of 2. And then we'll simplify. Negative x cubed, that's negative x cubed. Negative x squared gives us positive x squared. And what I want you to see here is that our x cubed term is the opposite sign and our x squared term is the same side. It's not the same, so it's not even. And then if I went ahead and factored out a negative, my function here in the parentheses is not the same as h. So it's not odd either. So this is neither even nor odd. Okay, please go ahead, pause the video. I have a practice one here just to see if you got the hang of it, and then we'll go over the answers. Okay, for this example, if you evaluate d of negative x, you're plugging in the opposite x value. I have negative 3 times negative x squared minus 1. Make sure you include the negative in front of the 3. My students often drop that. Don't know why. Don't drop that. Keep that negative there. And then I'm going to go ahead and evaluate. So I get negative x squared. That's a positive x squared. I get this. Hey, which is the same thing as d of x. So d of negative x gives me d of x. Opposite x gives me the same y. This function is even. That's even and odd functions. I hope in this lesson you learned what an even and an odd function is and how to determine if a function is even or odd, either through symmetry or by evaluating the function at the opposite x value. I'll catch you in the next video. Please thumbs up, like the video, subscribe for more awesome math videos. Catch you next time.